Traffic and Transport Impact Assessment. This presentation was prepared by Paul Carter, a transport engineer with over 15 years' experience in transport planning and traffic engineering. Paul's experience is focused on infrastructure planning and assessment, and he has worked on a variety of projects, including lead roles for specialist transport studies, forming part of various environmental effects statements. Paul's role on this project was as Project Director for ERUP, and this presentation summarises the traffic and transport impact assessment undertaken for the Fingerboards mineral sands project. As an overview, this presentation will cover the scoping requirements set out in the EES relating to this study, the study purpose, the study methodology including relevant legislations, policies and strategies, an overview of existing conditions, details of the project proposal and the impact assessment framework used. It will then cover the key findings and recommendations as an outcome of the study and provide a summary to conclude the presentation. Of the EES scoping requirements, the traffic and transport assessment primarily relates to the objective shown on this slide, specifically to minimise potential adverse effects on transport infrastructure. This study assesses the impact of the proposed traffic movements or changes to the transport network as a result of the project, and in particular, the approach to product transport. Product transport has relevance to a number of other evaluation objectives and environmental values, for example air pollution and/or noise vibration effects. However, this assessment is focused only on product transport impacts associated with transport safety, operational performance and road assets. This study investigates the traffic and transport impacts of the proposed project and the associated transport infrastructure requirements during the construction and operational phases. There are two main components to the study, which are: firstly, evaluating the existing conditions, which involved establishing the characteristics of the current transport network and surrounding land use, and identifying the key transport components of the project. Then secondly, assessment and mitigation, where risks are identified and recommended infrastructure upgrades and additional measures are defined to address these risks. The process underpinning the study is shown on this slide, with the project study beginning in March 2017. Since 2017, when initially briefed on the project, ERUP has conducted a desktop review of background data, including policy documents, available transport data including traffic volumes and crash data, infrastructure geometry and surrounding land uses. Undertaken site investigations in 2017 and 2018 and consulted with Vic Roads, Wellington Shire and East Gippsland Shire councils to understand their concerns as road authorities within the study area. Developed an impact assessment framework using a risk-based approach and used the framework to assess option impacts and develop mitigation measures to address the identified risks. This has been through an iterative process as the project was continually refined by CalBar across 2018 and 2019 and the project reassessed. The findings from this assessment have been documented in the Traffic and Transport Impact Assessment Report, with key findings summarised in this presentation. This slide shows the legislation, policies and strategies that underpin this assessment. In addition to the Environmental Effects Act, this includes the Transport Integration Act, setting out the overarching objective for the development of the transport network, including a focus on efficiency and safety. The Road Management Act, providing the statutory framework for management of all Victorian roads, outlining the powers of state and local authorities. The Local Government Act, which defines local government responsibilities and requirements for local roads and their maintenance. A number of relevant freight strategies and local Gippsland transport strategies were also reviewed for this study. The Austroads and Vic Roads guidelines were adopted in assessing the performance of the road network and identifying recommended mitigations. With the relevant policies and guidelines established, ERUP commenced the investigation to establish the existing conditions. This slide shows the study area for this assessment, which encompasses all the product transport route options that were assessed. The study placed particular emphasis on the impact to local roads and the connection between the project area and the Princes Highway. It focuses less on the Princes Highway and the South Gippsland Highway due to their current classification as B-double approved roads, and given that they are of high standard. The road network includes both declared roads, where Vic Roads are responsible, and non-declared roads, for which local government authorities are responsible. Generally, the declared roads meet the relevant requirements, though there are some instances on lower order roads such as Lindenow to Glenelladale Road and Bairnsdale-Dargo Road where the minimum shoulder requirements are not met. The local road network generally meets the requirements for its intended purpose. All roads within the study area are approved for B-double use, with the exception of the Fernbank-Glenelladale Road, Beverleys Road, Racecourse Road, Limpias Road, and some minor local access roads, for example Careys Road, Chettles Road and Cowles Lane. Traffic data was collated from a number of sources, including Vic Roads, Wellington Shire Council and East Gippsland Shire Council. This found that in general, there were low to moderate levels of traffic on the study roads, typically not exceeding 500 vehicles per hour, with the exception of Main Street in Bairnsdale. Consultation with East Gippsland Shire Council also noted that seasonal variation can be significant along the Princes Highway, with notable increase in traffic on school and public holidays. Whilst the public holiday weekday demands are shown to be significantly higher, the peak two-way demands of approximately 1,050 vehicles per hour are well within the road capacity. That said, there may potentially be challenges for some users in finding suitable gaps when turning to and from the highway. This slide shows crash statistics over a 5-year period between January 2012 and December 2016, with notable locations where there were 3 or more crashes, including Princes Highway Collins Street intersection, Princes Highway Racecourse Road intersection, Beverleys Road between Stockdale Road and Bairnsdale-Dargo Road, and the Princes Highway Forge Creek Road intersection. These statistics were considered when reviewing the safety impacts in the impact assessment for the proposed product transport routes. All modes of transport were considered in the study. The study area includes regional and school bus routes, with some school bus services also using key roads within the study area. Consideration has been given to these as part of the impact assessment. The rail network in the study area includes the Bairnsdale to Melbourne Railway Line, the Maryvale Freight Line and the Avon River Railway Bridge upgrade at Stratford. The Avon River Railway Bridge upgrade will improve passenger services and also facilitate rail freight services from East Gippsland to Melbourne. There are also a number of level crossings with active control flashing lights and also some with boom gates. Pedestrian activity in the study area is primarily limited to the towns of Lindenow South, Lindenow, Fernbank and Bairnsdale. High pedestrian activity levels are expected at times such as football matches at Lindenow South Football Ground, the Bairnsdale Racecourse and other major town festivities throughout the year. It is noted that there are higher pedestrian movements in other towns such as Stratford and Sale. However, given the existing freight traffic on roads passing through these towns and current road environment, pedestrians are already aware of large vehicles passing through these towns. During site inspections, a small number of cyclists were observed to use Main Street within Bairnsdale, with no other instances observed. It's recognised, however, that increased cyclist activity is expected within townships and some long-distance recreational cyclists using the declared road network. Having established the existing conditions, the study focus is on the proposed transport movements during both the construction and operational phases of the project. The construction phase is expected to be a period of 2 years, with up to 130 workers on site on a typical day, working across 2 12-hour shifts with 75% working during the day and 25% working during the night. This is expected to generate 150 return trips per day, with 1 return trip equaling 2 one-way trips. This consists of 20 heavy vehicle and 130 light vehicle return trips. During operations over a period of 20 years, it is expected that 120 workers will be on site each day across 12-hour shifts with a similar day-night shift split. 160 vehicle return trips are expected, consisting of 40 heavy vehicle and 120 light vehicle return trips. Heavy vehicle trips would be B-doubles used for product transport. A conservative assumption has been made for both phases, assuming that all workforce will travel by light vehicle with 1 vehicle per person. However, it is understood that buses may be provided to transport workers to and from the site. Various product transport routes were assessed as part of this study. It is assumed that by the time operations begin, the Avon River Bridge upgrade will be completed. While the primary intended benefits of this upgrade are to improve passenger services, it will also facilitate rail freight services between East Gippsland and Melbourne, allowing product from the mine to be transported via rail from East Gippsland to the Port of Melbourne. The product transport options that have been developed by Calbar are shown on this slide. Calbar's preferred option for product transport is a new, purpose-built rail siding at Fernbank East for product transport close to the project area. In the assessment, this is referred to as the Post-Avon River Bridge Option 1. An alternative option was also assessed, where the existing Bairnsdale siding would be upgraded and used for product transport rather than the new purpose-built siding. A pre-Avon River Bridge option was also assessed in the event that there are delays to the Avon River Bridge upgrade and it is not completed in time. This would see half of the product transported to Maryvale and the other half transported to Port Anthony or the Barry Beach Marine Terminal. This slide shows a map of the 3 proposed transport route options. The preferred option uses a purpose-built rail siding at Fernbank East that will be accessed via a private haulage road within the project's infrastructure corridor to access the siding from the project area, with the shortest road transport distance of all the options. The alternative Post-Avon River Bridge option will see product transported from the project site to Bairnsdale using Bairnsdale-Dargo Road and Lindenow-Glenelladale Road to the Princess Highway and then to Bairnsdale. In the event of delays to the Avon River Rail Bridge upgrade, a longer distance of on-road travel is required, with product transport using B-doubles to reach the Maryvale rail siding and Port Anthony. However, product transport using this option would cease once the Avon River Rail Bridge upgrade is completed. Following the existing conditions assessment, an impact assessment framework was developed to assess risks associated with the proposed transport routes, using a risk-based method considering environmental values, likelihood and consequences, and mitigation measures. The first step was identifying environmental values specific to the transport assessment. This identified 4 values which were efficient road network, transport safety, asset performance, and traffic operations during road upgrades. Any identified issues would be assessed based on their impacts to these values and the sensitivity of these environmental values to change. Each impact was rated for its likelihood on a scale of rare to almost certain and its consequence from negligible to extreme. Prior to assessing the impacts, the basis for each likelihood and consequence rating was defined for all the environmental values. As an example, when rating a transport safety impact, consideration was given to the infrastructure conditions, crash history, traffic increases, and number and severity of injuries. Examples of considerations for the remaining environmental values are provided on this slide. The risk evaluation matrix was used in the assessment of each impact to define a risk level from very low to major. First, the impact was assessed with standard mitigation measures to obtain the inherent risk. Standard mitigation measures are typically generic measures not specifically developed for the project and relate to minimum practice or legislative requirements. The impact was then assessed with additional mitigation measures identified and are recommended to reduce the risk of impacts as a result of the project, with a residual risk provided assuming the measure is adopted. The key findings from this assessment will be discussed in the following slides, focusing on impacts that were identified as high or major inherent risks to the environmental values. The following slides will run through the key impacts and mitigation measures for the transport route options. Given there are a number of impacts that overlap between the 3 options assessed, to avoid repetition, the findings will be detailed in the following order: a summary of impacts and recommended measures that apply for all options, items specific to the preferred option, items for both the alternative options, and finally, items specific to each alternative option. Impacts presented on this slide are associated with all the project options, including the construction phase. As part of the operations phase, the Bairnsdale-Dargo Road and the Fernbank-Glenelladale Road intersection will be modified. These roads will be realigned to facilitate mining with the existing intersection removed and a new intersection constructed to the southeast, which will also facilitate access to the site. For all options, this creates a crash risk at the proposed intersection, given the number of B-double and workforce traffic movements through the intersection in addition to existing traffic volumes if only standard intersection treatment is provided. Other impacts include Increased crash risk due to no existing lighting at intersections, including the Fernbank Glenelladale Road, Bairnsdale-Dargo Road intersection, the Princes Highway Fernbank Glenelladale Road intersection, and the Princes Highway Lindenau Glenelladale Road intersection, which is for the alternative options only. General driver crash risk from transport of product with B-doubles over the life of the project, and potential safety impacts from movement of oversize, overmass loads. To mitigate these impacts, mitigation measures proposed include providing a roundabout control at the proposed Bairnsdale-Dargo Road and Fernbank Glenelladale Road intersection that forms access to the site. This will reduce the speed of approaching traffic and mitigate cross-traffic conflicts. Provide lights or flag lighting at intersections where there is currently no existing lighting. For general driver crash risk, it's recommended that a transport operational management plan is developed that will address and monitor key issues such as driver fatigue, inductions, fitness for work, and vehicle and network familiarisation. This should be regularly monitored and reviewed, and driver surveys undertaken annually. Regarding movement of OSOM loads, it's recommended that these movements are avoided during peak hours and school bus operation hours. Additional high and major risk items for the preferred option only are outlined on this slide. As part of the preferred option, a new sealed private haulage road will be constructed, linking the site with the rail siding. This will cross a number of existing roads, creating potential risks at these locations. This includes increased crash risk at the proposed intersection of the private haulage road and Fernbank Glenelladale Road due to the introduction of B-doubles crossing the road. Increased crash risk at Chettles Road and Cowes Lane due to the B-doubles crossing these roads, which are currently unsealed public roads. Risk associated with road lighting at the proposed Fernbank Road private haulage road intersection due to a lack of awareness of B-doubles crossing at this location. Recommended measures to mitigate these risks include provision of a signalised control at the intersection of Fernbank Glenelladale Road with the private haulage road, with advance warning signs placed upstream of the intersection. In determining the final location of this intersection, consideration should also be given to providing appropriate spacing between intersections to reduce the risk of high-speed collisions and providing hazard awareness. It is also recommended to provide flag lighting at this intersection. On top of the standard measure of public road sealing at Chettles Road and Cowes Lane on either side of the private haulage road crossing, it is also recommended to introduce an operational overlay in the Transport Operational Management Plan requiring B-doubles to stop before crossing these roads. As the preferred option provides a new rail siding that is local to the project site, there is significantly less interaction with the public road network. This mitigates many of the impacts for the alternative options that will be covered in the following slides. For the alternative post-Avon River Bridge option using the Bairnsdale rail siding and the pre-Avon River Bridge option, there are a number of impacts common to both options. These routes have greater interaction with the road network and pedestrians as they pass through additional intersections, rail crossings and towns, creating additional potential impacts to the environmental values that were described earlier. Transport safety impacts for both options include increased risk at the Lindenau Glenelladale Road, Bairnsdale-Dargo Road intersection due to turning B-doubles at this intersection. Increased crash risk at the Lindenau Glenelladale Road level crossing given the large number of B-double movements and potential driver fatigue at night. Potential safety impacts to school buses due to the interaction with B-doubles. Increased risk of crashes involving pedestrians in Lindenau South due to increased heavy vehicle demand, especially times of high activity such as during a football match or school times. Specifically regarding safety around schools, there is an increased risk of crashes near Lindenau South Primary School and Lindenau Primary School during times where students travel between school and home. Recommended mitigation measures for these impacts include providing extended no overtaking line marking at the Lindenau Glenelladale Road, Bairnsdale-Dargo Road, and upgrading the Lindenau Glenelladale Road level crossing to incorporate boom gates. For mitigating pedestrian and school bus impacts, it's recommended that B-double movements avoid travelling during school pickup and drop-off times on school days. Pedestrian surveys should also be undertaken to understand the pedestrian patterns in Lindenau South. Additional measures that may be appropriate to consider include limiting operational times for B-doubles, revision to the speed limits and driver training, and familiarisation as part of the Transport Operational Management Plan. High-risk impacts to the asset performance and traffic operations during road upgrades were also identified for both the alternative options. These include pavement deterioration from product transport via B-doubles, resulting in reduced pavement life and uneven and dangerous road surfaces on routes including Lindenow-Glenaladale Road, Bairnsdale-Dargo Road and Barry Road for the pre-Avon River Rail Bridge option. There may also be traffic impacts along the Princes Highway from road and intersection upgrades constructed during peak periods. To mitigate these risks, it is recommended to develop a monitoring and asset protection plan that is agreed between the project and relevant road authorities, including maintenance of shoulders and improved drainage in addition to pavement treatments. A survey should also be conducted of the existing conditions of the final product transport route prior to construction commencing. This is so deterioration resulting from the project can be monitored and intervention levels agreed. To minimise traffic impacts, peak periods should be avoided when constructing any road upgrades. Specific to the alternative post-Avon River Bridge option, where product is transported to the existing Bairnsdale rail siding, there are also a number of key impacts. There is an increased crash risk at the intersections of Princes Highway at Racecourse Road and at Lindenow-Glenaladale Road, given the number of B-double movements and existing traffic volumes on the Princes Highway. Without road treatment, these vehicles would cause excessive slowing and safety concerns for general traffic concerns. Due to the alignment of Racecourse Road relative to the Princes Highway, it is observed that B-doubles are unable to remain within the traffic lane on the bend south of the intersection, presenting a crash risk with oncoming traffic. At the intersection of the Princes Highway and Racecourse Road, there is also no existing road lighting, also increasing the crash risk at this location. With the increased heavy vehicle demand, risks were also identified to pedestrian safety, particularly in relation to events at the Bairnsdale Racecourse. In addition to locations identified for both alternative options, pavement deterioration was also identified as a risk along Racecourse Road, Forge Creek Road and Bosworth Road. Mitigation measures for these impacts include upgrade of the Princes Highway intersections to a roundabout control to reduce approach traffic speeds and mitigate cross-traffic conflicts. At the Princes Highway Racecourse Road intersection, lighting should also be provided with shoulder widening and line marking on Racecourse Road south of the intersection. Pedestrian surveys should be undertaken to understand the pedestrian demand patterns, with mitigation measures that may be appropriate, including limiting B-double operating times, speed limit revisions, driver training and familiarisation. Development of the monitoring and asset protection plan and conduct existing conditions surveys for pavement deterioration. It is also recommended that minor works are undertaken to rectify poor drainage performance, and any sections that require localised shoulder widening and resealing and strengthening of pavement for B-doubles is to be developed and agreed with relevant road authorities, particularly for Bosworth Road, Forge Creek Road roundabout and Bosworth Road and the Bairnsdale rail siding access. Specific to the pre-Avon River Bridge option, where product is transported to Maryvale and Port Anthony, major risks include increased crash risk for the Princes Highway and Lindenow-Glenaladale Road, given the number of B-double right turn movements and traffic volumes on the Princes Highway if there is no intersection treatment, as this would cause excessive slowing by these vehicles. There is also a risk of vehicles queuing across the Princess Drive level crossing in Morwell near Maryvale due to the B-double movements given the short distance between the level crossing and the intersection at Princess Drive. This level crossing currently has full active control with flashing lights and boom gates. For these impacts, the recommended measures are: the intersection of the Princes Highway and Lindenow-Glenaladale Road is upgraded to have roundabout control, and it is recommended that detailed investigation be carried out in relation to signal operations and vehicle queuing at this location, and, if required, the existing line marking at the Princess Drive level crossing is reinstated, or consideration is given to linking the rail signals with traffic signals to ensure the queue is cleared prior to a train arrival. To summarise, the Traffic and Traffic Impact Assessment for the Fingerboards Mineral Sands project has assessed the project's impact within the study area. Existing conditions within the study area have been established, which involved a desktop assessment and site investigations to understand the current conditions. A risk-based framework was developed and used to assess the impacts in alignment with the approach that has been taken across the EES. Key impacts were identified for the preferred post-Avon bridge option, the alternative post-Avon bridge option, and the pre-Avon bridge option. This looked at impacts to transport network efficiency, transport safety, asset performance, and traffic operations during road upgrades. Based on the assessment, the option that is preferred by CalBar maximises the use of rail, which in turn minimises the interaction of product transport vehicles with the public road network. In addition, from the study, there are a number of key recommendations to address the key risks. While there are a number of recommendations, these primarily include intersection upgrades and safety improvements at key locations, including the provision of lighting, upgrade to the level crossing in Lindenow South, establishing a transport operations management plan, avoiding product transport during peak times for school traffic and peak activity periods of key land uses along the transport routes, and conducting assessments of the road assets to be monitored during operations.